Hello. In this video, I'm going to look at graphing equations. So whenever we look at graphing equations, essentially what we want to do is think of, like how do we find the graph, if we don't know its basic shape? Well, one thing that we can do, for example, is by finding the intercepts. So we can look at finding the intercepts, which in this case, what we mean by that is, like if we have that there's a x-intercept right here, or if we have that there's an x-intercept right there, y-intercept, sorry, then we can do that. The second thing that we can do is to find as many additional points as needed. Okay, so we'll just say that we'll just find any additional points. Okay, so aside to the x-intercept, maybe we could have another beyond the y-intercept, and like maybe we might have that it passes through another point like over here, perhaps. Okay, the third step is that we can just plot those points, but in either case, that's kind of like what I've been doing right here, is just by plotting some points. And maybe we can plot another point, like for example, like right here and right here. Now the fourth step is that essentially you want to join the points with a smooth line or curve. So we'll just say join the points with a smooth curve or line. Okay, now in this case, we actually do have a line that can be formed with these sets of sets of points, actually, of which we try our best and we get that this is approximately what that graph might look like. Now, keep in mind that you would actually need an equation technically for this. Now, in this case, the equation that correlates to the one that we have right here is y equals to x plus 2. So you might wonder, well, how did I know that it's going to be these points right here? Well, I would just make a table essentially. Like I would say, okay, well, here's x, here's y, and like we have that we plugged in -2, -1. Let's see. Actually, this is another point right there, isn't it? Yeah, but that's okay. So we can do like -1, and then we can do 0. And if we plot these points, then in that case, see, because the scale, yeah, it has its in increments, right? Okay. So when we plug in -2, -2 plus 2 is 0, -1 plus 2 is 1, and then 0 plus 2 is actually going to be 2. So, like if we had, we don't need this. If we had that, just that we were starting from scratch, then yeah, sure, we would plot this point right here. We would plot -1, 1, which in this case would be right there. And then we would have 0, 2, which will be that. And then the step that we have is that, well, we just need to join these points as needed. And this would be the graph of that equation, right? So this is our graph of our equation. And we can repeat that for, many other types of points, for example. So, okay, well, let's say that we wanted to try this with another type of equation, or, a specific type of equation. And maybe we'll use this, right? We'll use this one so that we have it. And let's clean this up a little. And let's say that we have the equation y equals to x squared plus, we'll use x squared plus 1. Why not? Okay, so we'll make our chart. So we make our chart, and, well, rule of thumb is to kind of just plot any points as needed. So like, for example, like -1, 0, 1, and then maybe like 2 even. Okay, so we'll plug in 2. Now, notice that in either case, you're plugging these into the equation, right? So negative 1 squared plus 1, that's equal to 2. 0 squared plus 1, that's equal to 1. 1 squared plus 1 is equal to 2. And then 2 squared plus 1, that equals to 5. Now, notice that in this case, I kind of omitted the whole thing about, like, okay, well, I need to get the x-intercepts in either case. Well, unfortunately for this one, there are no x-intercepts, so yeah, that's why I didn't even look at it. So I have negative 1, 2, and then I have 0, 1. I have 1, 2, actually, right? So 1, 2. And then we have 2, 5. Now, 2, 5 actually looks like it's going to be at this upper point right here. So in that case, like what we can do is try to join the points as best as possible. And we'll have something like this. And yeah, it's going to be rough sketch, but it's okay. And then now notice this though. If you plug in negative 2, you will get negative 5, or you get 5 also. So in that case, we have that, we could actually just reflect it over here. And then we can just join these points right here so that we have what is called a parabola, essentially. And there's our graph. It's a rough sketch, but no worries, because in either case, yeah, it's off by a little bit, but that's okay. So we have our graph of x squared plus 1 equals to y. Now, if I wanted to say, for example, talk about finding solutions in either case, I can also do that as well in either case. Now, say, for example, that, like we had an equation and like we wanted to know, for example, like what are the x-intercepts, y-intercepts. So in this case, I'm going to go ahead and explore how do we find an x-intercept. An x-intercept is when the x, or when the y, is equal to 0. What is a y-intercept? A y-intercept is when you have that the x value is equal to 0, and then you get the y, right? Now, let's suppose that we have an equation such as like x squared minus 4. Now, accordingly, how do we find the x-intercept? You set the y to 0, so that's going to be 0 equals to x squared minus 4, which this gives us x squared equals to 4, which we take the square root on both sides, and we get that x equals to plus or minus 2. Now, that gives us the ordered pair 2, 0, and negative 2, 0. But how do I find basically... Okay, so that's the x-intercepts, right? But how do I find the y-intercepts? In a way, the y-intercept is probably the easiest one to find in some cases, because what is a y-intercept? It's when the x is equal to 0. So y equals to 0 squared minus 4, and then that gives you 0, well, it gives you minus 4, right? So it gives you minus 4. So that's 0, negative 4. So I was kind of jumping ahead. So what does that mean for us? It means that we actually have enough to plot the entire graph, actually, in either case. We have 3 points that we can use to define the shape of the graph. And why don't we do this? Let's go ahead and grab this right here. And I think it'll be okay, because, I mean, let's see. We just need to erase some of this off of here. I think next time I'll probably just scroll down a little more. Okay, so I think that's good enough. Okay, so what was our goal? Our goal was to figure out the graph of y equals to x squared minus 4. And what points did we find? We found negative 2, 0, 2, 0, and 0, 4. What do I do next? Well, what I do next is I basically just tried to draw a smooth line that forms with this graph. And then we have that we want to do the same thing where we try to join right there. So in this case, this is our graph of our equation, right? And it's a rough sketch, but that's okay in either case, because, you know, like, you're just going to be drawing these, right? So this is our graph right here. Now, you can label these points respectively as 0, 4, 2, 0, and negative 2, 0. And, you know, if we wanted this to be a bit more accurate, you know, we would have plugged in 1, and yeah, it would have to be like that it passes through here, and it passes through, well, 1 actually would be right there, right? Like 1, 3. Oh, it is, yeah. Actually, it's a little good. So, where is 1? 1 is right here. Where's 3? Yeah, it's a little off, but that's okay. Because the logic is that the more points that you plug in, the more fine that the graph will become in actuality. Now, of course, I can actually plot this in my graphing calculator, where basically I just need to write it as the equation y1 equals to x squared minus 4. And of course, you know that you would just input that into the graph section of your TI-8384, and you would just click graph, and it would give you the exact same thing. Of course, you know, future assignments will require that you are able to find the sketch of a graph in either case for any function that given. And so, you know, like, it's good to know like how to do this by hand in either case. So you can always check, for example, that an equation is satisfied by an ordered pair that lies along the line, of which, you know, that's where I can probably stop where I just mentioned, you know, like, you can always verify solutions. You know, like, if I have that I want to verify that, for example, that 1, 3 lies on y equals to 2x plus 1, I can actually verify this also. How? By plugging in. So 3 equals to 2 times 1 plus 1, which, you know, we would wonder, is this in fact true or not? Which, of course, it is. So, you know, just like you were plotting points into the equation and solving for the y pair, or the other way around, you can also verify that points lie on the line by just plugging them back into the equation. And that's kind of, you know, very useful in either case when it comes to looking at solutions that satisfy an equation in either case. So that's going to be it. You know, try plotting perhaps like something like, if you have the square root of x, like, what does that look like? Try using also y equals to the absolute value of x. You know, like, what does that look like in the x and y plane? And then maybe try also y equals to x cubed. Now, note that we already, we didn't actually look at x squared actually, so why don't we just go ahead and add in y equals to x squared, and you'll look at those graphs. Now, these graphs are actually pretty standard when it comes to graphs of equations, and, you know, in a few sections from now, that's what we're going to be looking at, which it's good to know kind of like the shape of this graph, this graph, this graph, and this graph.